Find Vx in the circuit using superposition principle. Using superposition theorem. What are the circuit elements here? DC circuit or AC circuit? Do you know the AC fundamentals? Or we have to review? This is AC circuit. Yes. You need revision. Okay, but they are not raising their hand, no? Boys all know AC. This side, all know? Raise your hand if you want revision. Otherwise, don't. Okay, sit down. Yes, leave it. If you plot between time versus magnitude, that is voltage. In this case, voltage. It may be current also. Plotted time versus voltage V. This is DC or AC? DC. Okay. This is AC. What is the difference? It is varying with respect to time. The voltage is not constant. This is identical to your house power supply. House power supply is like this. It is varying like sinusoidal signal with a constant amplitude, constant frequency, constant amplitude. This is constant. That is Vm. This is minus Vm. Amplitude is constant. How this wave is, why this AC is convenient for handling? Why not DC? Huh? Losses. AC can be? I can't get you. Again, tell me. DC also can be stepped up and stepped down. No. Your answer is partially correct. Easily can be stepped up and stepped down. A static device can step up and step down. What is static device? That static device that step up or step down? Transformer. Transformer is a static device. If a device is static and it do something means its efficiency will be higher. The efficiency will be higher. Transformer efficiency may be 99%. No other device will have that much efficiency. Above 90% efficiency. No mechanical device will have that much efficiency. So easily we can step up without mentioning the device he mentioned. So easily it can be stepped up and stepped down. That is one of the reasons why we are using AC. How it is generated? Suppose you are having a two-pole machine. You are having a two-pole machine. You need a north pole and a south pole is required. Suppose you are having a coil of rectangular coil. This is to understand AC. This is to understand. This is to understand. Only one coil is there. When EMF will be generated in a conductor? Whenever there is a flux change, that EMF is directly proportional to rate of change of flux or velocity. At what rate it changes. So this is fixed. This is fixed. But this is rotating. this rectangular coil is rotating. Rectangular coil is rotating. It is rotating like this. It is rotating like this. The magnetic flux is this way and it is rotating like this. When the rate of change of flux will be maximum, you think that this finger and this finger are conductors. And this is magnetic field. If this conductor is in this position, initially in this position, if it small displacement, if we consider, what is the line of displacement? Flux and displacement are in the same direction or opposite direction, but anyhow it is parallel to flux. If it cuts the flux, rate of change of flux will be maximum. If it travels along the flux direction, there is no induced EMF. Fleming's right-hand rule. What he says, this is field. First finger is field, F for field. The middle finger is conductor. These should be perpendicular. Perpendicular to each other. That time, that direction of motion is perpendicular to both. Perpendicular to both, then there is an induced EMF. But if flux is in this direction, the displacement, if you think, the displacement is along the line of flux. It is not perpendicular. But if you consider this small displacement, if we consider, it is perpendicular to, exactly perpendicular to flux. That's why that time the EMF induced will be maximum. But if we inclined, this small displacement you consider in this, here this can be resolved in two components. One is horizontal displacement and vertical displacement. So it consists of both vertical and horizontal. So only for vertical displacement only there is an induced EMF. It consists of two components. If it is in this position, no vertical component, only horizontal component along the flux direction. Along the flux direction only displacement, no EMF. If it is in this maximum EMF, you inclined, it has both displacements, horizontal as well as vertical. Horizontal as well as vertical. For vertical component only, there will be induced EMF. That's why it is in between the maximum and the minimum. If it goes up, gradually voltage increases and maximum. If it comes down, gradually decreases, comes to zero. That's why it is varying like sinusoid. When it is rotating in the magnetic field, it is varying like this. When it is displacement is parallel to flux, it is not obeying Fleming's right-hand rule at this point. That's why there is no EMF. It gradually inclined in means vertical component comes. That's why gradually increases at this point VM, maximum voltage. Again, it comes to vertical, then it goes this way, means gradually vertical component decreases, and again vertical component becomes zero. At this point, again it becomes zero. During that time, what is the angle of rotation? 50%. Out of 360 degree, 180 degree completed. That's why this angle is pi degree. 180 degree completed. Then further you are rotating, but this here, suppose this is north pole, it cuts this way. Cuts this way. If the same conductor comes this side, it cuts this way. In opposite direction, it cuts. That's why the current direction will be in the opposite way. So in the same conductor, current decreases and comes to maximum in 90 degree. Another 90 degree, again it becomes zero. Again it starts from left hand side. So for complete rotation, it goes to maximum, then decreases to zero, then come again, negative maximum, again comes to zero. So it repeatedly happens when it rotates. So DC we cannot produce because we can rotate easily. How a constant change in flux, how we can keep? It's not possible, no. That's why it is varying voltage we are getting. A sinusoidal voltage we got. A sinusoidal voltage we got. This is VM, maximum voltage is VM, and it is varying like this. To represent this, we need a constant value. we cannot represent it by Vm because that is the maximum value only. It has zero value, it is middle value. So many values are there. That's why we cannot represent them in terms of Vm. Or else you have to mention that it is the maximum value of that sinusoidal signal, like that you have to tell Vm, V suffix M, maximum value. But we used to represent this by root mean square value. For that, if you integrate this, what you will get? Area under this graph you will get. If you integrate this waveform, suppose this waveform is the maximum value Vm sin omega t. Am I correct or not? Sin omega t. Omega is frequency at which it rotates. So Vm sin omega t, that is the waveform. If you integrate that, you will get area. If you integral of Vm sin omega t, if you integrate 0 to 2 pi, if you integrate, what you will get? Total area. How much area you will get? If you integrate, how much area you will get? Let us assume that this area is 1, this area is 2. How much area you will get? Huh? 0 you will get, because that 1 is positive. The same amount of area you will get for negative waveform. That's why it becomes 0. That's why you cannot represent by average value. Average value means you have to integrate, you will find total area divided by 2 pi. Average you will get, because length is 2 pi. If you find average, it will give 0. That's why we cannot represent by average. But I am taking 2 containers, same amount of water it has. In one container, I am using a resistance to heat this. For that voltage is V. I am using voltage of V. Current through this is I. This temperature is raised from room temperature, say 30 degree to 100 degree centigrade. Some power is spent, some energy is spent on that to raise the temperature from 30 degree to 100 degree. Here, I am using the same resistance, but here I am giving AC. I am giving AC. I do not know the value of AC, but I know the value of DC. That is, say 100 volt. 100 volt DC I am giving, but I do not know the AC value. For the same 10 minutes, this also raised same amount of heat. Initial temperature is 30 degrees centigrade. It raised to 100 degrees centigrade. The same duration of 10 minutes. Let us assume. Then the AC is equal to 100 volt RMS. AC is equal to 100 volt RMS. That is called equivalent voltage. Because AC is 50% of the time it travels one direction. Another 50% of the time it travels in the opposite direction. Actually, what is happening here is the electrons are moving towards right for half of the cycle. Another half of the cycle, it moves to the left. So it never moves away. The electrons are moving forward direction and backward direction. It vibrates. It is actually not moving one direction. It is not moving to one direction in AC. It moves towards right for half of the cycle. Another half of the cycle, it moves towards left. Again, moves right, moves left. That is happening in the AC. That AC is used here to raise the temperature from 30 degree to 100 degree centigrade. Here, everything is same. Initial temperature of both water is same. The maximum temperature, it raises to 100 degree centigrade. That is also same. Quantity of water is same. Time duration is same. Everything is same. That means the energy spent on both are same. In that case, the AC voltage, the RMS value of AC voltage may be called 100 volt. That is the meaning of root mean square value. Root mean square value means a square root is required, because root Mean means you need average, 1 by 2 pi. Root mean means you have to integrate, then find average. So square root of Vm square sine square omega t dt. So you have to square, integrate, find average. You squared, that's why you are finding square root. Root mean square value. That root mean square value give the same equivalent DC value. That's why we used to call that AC in terms of RMS. If you find the RMS value for this, it will be 100 volt. If you find the RMS value for this AC value, it will be 100 volt. That's why we used to call AC, because energy, there must be meaning. There must be meaning. Why we are calling 100 volt? Because it gives the effect of 100 volt DC. It gives the same effect of 100 volt DC. That's why the meaning of root mean square value is DC equivalent. It is DC equivalent. We forget all these things. These are all not required. If they give voltage means RMS value is given. Any voltage give in any problem is 50 volt. If they said what is given, average value or maximum value or RMS value. RMS value is given. Don't think about maximum value or average value or other values. It is only RMS. So we used to say 220 volt means maximum value will be about 220. Maximum value will be about root 2 times 220. Root 2 times 220. Vm by root 2 equal to RMS. Therefore, Vm equal to what? Root 2 times RMS. It will be more than 220 volt, but we are calling it as 220 volt effective value or DC equivalent value we are calling. That is one point you should learn. The second point is in phase. In phase. In phase means you can plot for voltage as well as current. I am plotting for voltage. Now I am plotting for current. Let us assume that this is the current waveform. This is voltage waveform. This is current waveform. If you find RMS for this 220 volt, current is 100 ampere. Let us assume RMS value. I plotted here time versus voltage as well as current I have plotted. If you use small letters, it means you are talking about instantaneous values. Small letters means you are talking about instantaneous. Here instantaneous value I am talking. Here 220 volt means your RMS value you are telling, capital V. 100 ampere means you are talking, 100 means you are talking RMS value. Here I cannot put capital I. Here I have to put small I only, because it is instantaneous value in the waveform. Here I have to put small v only, because it is instantaneous value. Okay, this is called in phase. In phase means simultaneously both voltage and current are increasing. Simultaneously it becomes zero. Again simultaneously it comes to negative maximum. Simultaneously it comes to zero. This will happen only when if you pass this voltage, if you pass the voltage through a resistance. If you pass the voltage through resistance, simultaneously voltage and current will increase. We are giving voltage only. The current also follows the voltage. The pattern will be same. Suppose I am passing this on a coil, inductor. First, if you talk about inductor, you must know one thing. Inductor means what? A conductor wound on a core. Air may be a core. Air also a core. It means if you wind the coil, like the twine will be available in the bobbin, you know. Like that, if you wind a wire, then it is called inductor. Then it is called inductor. If you apply DC to that inductor, no potential drop. No potential drop. It acts as conductor. It acts as conductor. I am taking a conductor, I am winding on a core, say iron core. This is iron core. In that I am winding a conductor, not resistance. Conductor. It has zero resistance. That is wound on this iron piece. If you give DC, it is nothing but short circuit. It is nothing but short circuit. If you give AC, it is not short circuit. It is not short circuit. That's why in a fan, what is there inside? It is a coil. Copper conductor is there, not resistance. The fan has copper conductors wound on a core. It is inductor, not conductor. It becomes inductor. If you give AC, it is not short circuit. It is not. It opposes the flow of current. That inductor opposes. Because of that, what happens, what happens, this is voltage means, this is voltage, small v in 90 degree. There is a delay in 90 degree. There is a delay in 90 degree. Pi by 2. The current will increase after delay, but there is no power. It's called phase shift. That is called phase shift. Phase shift. Phase shift. So if it is pure inductor, note the word pure inductor. It means copper doesn't have any resistance, means if angle 90 degree, that's all. There will be a phase shift only. There will be a phase shift only. But here there will be a power loss. P equal to V into I, or I square R, or V square divided by R. There will be a power loss. Here, what is the power loss? Power loss equal to 0. If it is pure inductor, no resistance in the copper. Copper has resistance. That's why there will be a power loss. If we neglect that power loss equal to 0. Power loss equal to 0, because the I has a phase shift of 90 degree. That's why the power in AC circuit is not simply VI. This is VI cos phi. The phase shift is there. Cos 90 becomes 0. That's why power loss equal to 0. No power loss. No power loss. Power loss means it must get heated. It must get heated. Resistance means there will be a power loss, means it will get heated. But it won't get heat. That's why power loss equal to 0. Pure inductor means. But copper has some resistance. That's why there will be heat. Let us assume that copper doesn't have any resistance. Pure coil means there will be a phase shift only. There will be a phase shift only. Suppose I am having pure capacitor. Capacitor means what? What is the definition for capacitor? Capacitor means two conductors are separated by a dielectric medium. Insulator, in between them there is an insulator. DC will not flow through this because in between two plates, what is there? Insulator. That's why DC cannot pass through capacitor, but AC will do. AC will do. If it is a capacitor, even though insulator is in between them, AC will pass through. AC will pass through. If you take an inductor and if you pass AC, this is voltage. What will happen? The current will lead. Lead means here maximum means it will be maximum here. Here it will be maximum. It came 90 degree in advance. If it is a pure capacitor, no ideal inductor is available in the world. No ideal insulator is available in the world. That's why there will be a power drop. What is power? Here the phase shift again, P equal to VI cos phi. The phase shift between the voltage and current is again 90 degree. That's why VI cos phi equal to 0. There is no power loss. But there is a phase shift between voltage and current. Current will lag. Pure inductor means current will lag. The phase shift between V and I is 90 degree, but current lags. Therefore, I can say that lagging, if I take V as reference, most of the time we will take V as reference. Two persons are running. I can say in two ways. One person is lag reference. You have to take voltage as reference, and we have to take voltage as reference. That's why current is lagging. Lagging phase shift of 90 degree. The current is lagging by 90 degree. Here, current is leading by 90 degree. Current is leading by 90 degree. But if it is pure inductor, lagging 90 degree. Pure capacitor, 90 degree leading. If it is a combination of resistor and inductor, resistor means in phase. Resistor means in phase. Suppose here I am having another combination of resistor and inductor. It means neither 0 nor 90 degree. It is in between 0 and 90, but lagging only. Lags, but angle is 0 to 90 degree. In between 0 and 90 degree. Suppose I am having resistor and capacitor. In this case, leading only. Again, angle 0 to 90 degree only. Pure capacitor means 90 degree leading. But a combination of resistor and inductor, resistor and capacitor means angle leading only, but angle is 0 to 90 degree. Inductor means lagging. Lagging means which is lagging? Current or voltage? Current is lagging. Current is lagging by 0 to 90 degree. Have you understand this point? Okay. Suppose I'm having combination of three. I'm having resistor, inductor, and capacitor. In that case, the phase shift will be either lagging or leading. Which dominates? If inductor dominates, lagging. Capacitor dominates, leading. Both are equal, no effect. In phase. If inductor effect and capacitor effect are equal, then the circuit is called resonance. The circuit is called resonance. Inductor effect that wants to lag the current. Capacitor wants to lead. Both are equally doing means getting cancelled. That's why resistance effect only. That such circuits are called resonance circuits. We will study later. But here we cannot say leading, lagging, depends upon the magnitude of lagging and the magnitude of leading given by inductor and capacitor respectively. Based on that, we have to tell leading or lagging. Okay. Suppose how to find all these things. Resistance is represented by R. It should be completed, otherwise incomplete. Resistance will be represented by R. Inductor will be represented by reactance, not resistance. Reactance. This is resistance. This is resistance. This is X is called reactance. Reactance can be classified in two ways, XL and XC. XL will delay. XC will lead. XC will lead. XL equal to 2 pi FL. L is inductance. XC equal to 1 by 2 pi FC. It doesn't give any power loss. That's why it is imaginary part. That's why J is involved. It is imaginary part. That's why J is involved. This is also imaginary, doesn't give any power loss. That's why J is involved, but minus. Why J is there? Because there is no power loss. Imaginary part. Only it gives phase shift only. This XL and XC creates phase shift. XL and XC. XL is reactance, inductive reactance, capacitive reactance. This will give you a phase shift of 90-degree lagging, and this gives 90-degree leading. This gives 0-degree phase shift. There is a power loss here, no power loss, no power loss. That's all.